Good afternoon. God, you guys are quiet already. I know it was lunch, but it's not that bad. Welcome to the architecture talk on Exchange Server 2016. Hopefully you'll enjoy it. Ready? Thank you, finally. Okay, 4 things I want to cover. The fundamentals of the architecture, client connectivity, namespace planning principles, and then we'll end with the preferred architecture and what's been changed with the release of Exchange 2016. First and foremost, Chewbacca was found sledding down the skyscrapers in Chicago this week. So I captured that on video for us. So, the server role architecture. At MEC 2012, I announced what our architecture looked like for Exchange 2013 and discussed how we changed the architecture to evolve it to support growing from very small scales to hosting hundreds of millions of mailboxes in Office 365 by changing the paradigm around what the dimensions along these 4 areas: functionality, versioning, user partitioning, and geographical affinity, and how we move from a multi-server role architecture to a 2-server role architecture to provide 2 distinct building blocks. Well, in exchange, and beyond that, I've always told you, time and time again, deploy multi-role. Don't deploy dedicated roles. So, how many of you followed my guidance and everyone else's guidance? Well, that's a good percentage. It's not what I wanted. But thankfully, we've changed that because I've taken the option away. So we now have a single building block architecture that includes the client access service components, that intelligent proxy that makes the decisions of where to route the request based on the user's mailbox's location, and the core protocol units that do all the data rendering, processing, and storage of the data. And all that forms into a high availability unit known as the Database Availability Group. You may notice some other things on this slide that we'll go through. First and foremost, Edge Transport Server Role will ship at RTM in Exchange 2016. How many of you use that? I just want to know. Few. How many of you are doing it for hybrid reasons? Just a handful. Yeah, get yourselves up over there. I know you guys use it. Okay, interesting. Good information. Last one that we'll cover, there's a new one down there, the Office Web App Server Farm. Can't say anything else. So we'll move on. The first thing I want to cover is this notion of every server's an island. We can break down an Exchange server along 3 core pieces. You have the protocols, like layer 7. You have the middle tier logic, which is all the business logic that does all that data rendering, data transformation. And then you have the storage layer. And prior to Exchange 2013, we had problems along that versioning and functionality boundary where we allowed the different layers to communicate to the different layers on another server. So we could have a protocol on server 1, submit and deliver mail to the storage layer on server 2, which meant that the protocol had to have some business logic layer built into it. And it also meant that from a versioning perspective, we had to be very tightly coupled. We couldn't allow differences in major versions to communicate along this pathway, because then it restricted how we could develop the storage engine or how we could develop the transport engine, depending on which way we're going, major up level or down level. It complicated things tremendously, as well as the fact that we always relied on RPC for all this communication pathway. So in Exchange 2013 and later, we changed that paradigm by forcing all communication between servers to go through the protocol stack, thereby ensuring that once we get the information to the correct server, we drive that information down the server. So we do all the data transformation, data rendering, all on the server where that data is supposed to be located. That freezes up from the whole versioning dependency that we've had in the past several releases. We now don't have to worry about it because everything's local. Once we get it to the box, it's good to go. There's no version dependencies. And then we ban this type of communication pathway, preventing that flow from ever occurring. Another way to look at that is that the answer is 42. Or that for a given mailbox's connection, the protocol that's always going to service that connection is always local to the active database copy where that mailbox resides. So if I'm using OA, I'm going to authenticate against a CAS service somewhere in my infrastructure. I'm going to be authenticated, and I'm going to be routed to the mailbox server hosting my active database copy. That's the server that's responsible for generating the look and feel of OA, for rendering all the data, for allowing me to edit attachments or whatever. All that occurs on the server hosting my active database. No other server's doing that. So now we get this great flow from that every server's the island. It also is what drives our ability to remove affinity at the load balancing layer, because now everything always ends up at one single place, the mailbox server hosting my active database copy. Nowhere else is there going to be any processing of that connection. We've also made some topology requirements with the release of Exchange 2016. First and foremost, Exchange 2007 will not be supported to coexist with Exchange 2016. So how many of you still have 2007 in the environment? Handful of you. You're Brent's pain point. I know. How many of you still have 2003? Let's ask that question. I saw these two. Wait, is that Jared? You can't raise your hand. And there's one all the way over there. Huh. Any 5.5 customers still left? No one wants to even raise their hand for that one. Okay. We've also made some changes around our operating system requirements. We're only going to support 2 operating systems with Exchange 2016, Windows Server 2012 R2 and Windows Server 10. One of those reasons is because of changes we're making with the database availability group and the need to no longer require an administrative access point. We actually, by default now, will not require one when you go to create a new DAG in Exchange 2016, which is a great thing because you don't need an administrative access point ever. So if you're utilizing some software that requires it, move to a different software provider that doesn't require it, or get them to upgrade to use the correct APIs to get the information they need. From an Active Directory perspective, we've made some changes here. Some of those may be rather significant for your planning perspectives. First and foremost, we require a minimum of Windows Server 2008 R2 as the Active Directory server version. Windows Server 2003 has lived a long life, but it's time to let it go. Likewise, for Forest Functional Mode, we have worked with the Active Directory team to determine what should be the minimum recommended level for our customer base, and they and us agree that it should be at least Windows Server 2008 R2. Obviously, we recommend going higher because of all the great enhancements that come with enabling, say, Windows Server 2012 R2 Forest Functional Mode. So definitely evaluate what those are. The Outlook client requirements. Outlook 2010 or later, you'll notice there are specific patch levels recommended there. One of the things that we've recently done with the on-premises release with Exchange 2013 and Office 365 was to develop a series of TechNet pages known as Office Updates. And one of those sub-articles is Outlook Updates. And it lists the minimum required versions and the recommended version that you should be deploying, whether you're on Office 365 or deploying on premises. We routinely update those minimum required levels as we fix certain related issues. For example, Outlook 2010, there's 2 KB articles. Those are the April 2015 public updates. They enable full support of MAPI HTTP in the Outlook 2010 client. So those are definitely recommended if you want to move to that on premises. And they're required if you're utilizing Office 365, as Office 365 is rolling out MAPI HTTP across the board. The KB article reference for Outlook 2013 fixes some issues that we found with shared mailboxes and legacy public folder coexistence with Exchange 2010. With that KB, which is obviously included in the 2010 patches as well, that enables us to fully support Kerberos authentication in a Exchange 2010, Exchange 2013 coexistence environment. Likewise, these minimum patch levels will need to be carried forward with Exchange 2016 coexistence. Of course, everything's subject to change on this slide as we determine final things in the future. So the mailbox server role. Two key things that it does. First and foremost, it will authenticate any client connection, do a lookup, determine the mailbox version, the location of that mailbox's database. If it's an OA request, it's also looking at the target site's external URLs for the OA virtual directory. And then it makes a decision. Where am I proxying this request to? Or where am I doing a redirect in the event of an OA redirection event? The second thing that the mailbox server role does is house all the components that store, process, and render the actual data. This is where all the protocols are actually doing all the data transformation and data rendering, etc. From an architectural perspective, what you see in IIS, as an example, is very similar to what you saw in Exchange 2013. If you deployed multi-role, you have two websites, a front-end website and a back-end website. The front-end website is TCP 443. That's what the clients hit. The back-end website, what is that one? TCP 444? I forget. Yeah, I was right. Greg says I was right. That's recorded now. Greg says I was right. It still works. I'm the only one who has a mic. I had to say it. So no clients connect ever to the back-end website, TCP 444. They only connect to the TCP 443. Likewise for SMTP and POP and IMAP, they're all split out and separated. And we're doing some improvements there. We want to separate the application pools from front-end and back-end to help with some performance-specific issues that we found with some larger deployments. So we're making changes there. The DAG is still our unit of high availability and site resilience. So you join a bunch of mailbox servers together to form that cohesive unit. It's still limited to 16 member servers, 100 database copies per server. We have made other improvements, though. Kareem mentioned that we're setting Replay Lag Manager to be on by default. I've already mentioned that we're removing the need to specify an IP address when you create the DAG. And due to some enhancements we've made with how passive database copies are accessed, database failovers are now 33% faster than they were in Exchange 2013. But there was one thing Kareem didn't mention in his talk that I get to announce. I cannot believe you guys. You fell for that. God, I should just leave now. No, we are still on easy. We will always be on easy. All right. So getting back to reality. Search. Kareem talked. How many went to our Meet Exchange 2016 talk? All right, a good handful. So Kareem talked about all the search enhancements we've made that transcend into user. But there were certain search enhancements we made that are really more for us as architects and deployment specialists. First and foremost is I'll cover what we did in Exchange 2013 to then tie in with what we did in Exchange 2016. Prior to Exchange 2013, every time a message came in, every recipient copy was indexed. Huge waste in CPU cycles. You know, if you have 30 recipients on that message, that was 30 times that message was indexed, plus then it was indexed on each database copy, plus every time the mailbox was moved. It was ridiculous. So we optimized that in Exchange 2013 at the transport layer. Prior to bifurcation, we submit that message into the content transformation service. The message is then annotated with a keyword list that's stamped onto the message. The message is then submitted back into transport, and it is delivered to store, at which point an index is kicked off, and the index will then read that message, read the annotated word list, and populate it into the index, thereby bringing the index up to date. Now, where we somewhat failed in that mission is that we did nothing for the passive. The passive copy still had to go and read the active copy, which was the architecture we introduced in Exchange 2007 and carried forward with Exchange 2010. And all of you who attended MEC 2012 all groaned at me when I said, yeah, we're not reading from passives. So we do this now. Problem solved. We've enabled access to read from the passive database copy, thereby removing any WAN dependency on index updates for the search infrastructure. This is a 40% savings on bytes over the wire alone in our new architecture with Exchange 2016. Isn't that awesome? 40%. You're still in shock about the sequel announcement, I see. We also made enhancements to the lag copy. I mentioned that Replay Lag Manager is enabled by default. For those that don't know, Replay Lag Manager was a feature we introduced in Office 365 originally and then shipped into Exchange 2013 on premises that, once enabled, would evaluate the health of all the rest of the database copies. And if there were not a certain number of healthy database copies within a 24-hour time period, 3 copies to be exact by default, we would automatically begin playing down the lag copy, thereby bringing it up to a highly available database copy so that in the event of further failure, we could activate and fall back to that. So we purposely made essentially a statement that said database availability is more important than point-in-time recovery in those scenarios. Great feature. We would also play down lags when there's physical corruption detected in the database copy or when there is capacity concerns on disk. What we found, though, is that during times when we started to play down the lag copy, that if it was during a peak user load, say Monday morning 6 to 9 a.m., that it could affect user activity, especially in the preferred type of architecture where you have 4 database copies on a single disk and one of those copies, at least, is active. And we don't want to affect the user workload during these type of playdown events. So in Exchange 2016, we've introduced some new monitors. One of those is an I/O latency monitor that evaluates the health of the disk. If the disk is above 20 milliseconds and we initiate a playdown event, we will artificially delay that until such time that the latency is below 20 milliseconds. The only time we ignore the 20 milliseconds latency is if there are capacity concerns on the disk and we know we need to play it down to ensure that all copies aren't affected. But this will reduce the variance in I/O as we do log replay. It essentially makes lag copies I/O free from this perspective. That's what Kareem was mentioning with a reduction in I/O. This is where that comes from the lag copy. It's now essentially a capacity feature as opposed to something we have to balance from an I/O and capacity aspect. That one server role that I mentioned that was new, the Office Web App Server. So in Exchange 2010, with Outlook Web App, we introduced document preview and the ability to access and read documents, Word documents and PDF documents specifically, in the OWA web browser without having to need a full fidelity client. Great feature, very widely used. and was carried forward in Office 365 and the future. We also developed the Office Web App Server feature, which is what SharePoint leverages to do document collaboration and document rendering without requiring a full fidelity client. As we progressed in Office 365, we moved to leveraging Office Web Apps for all of its content rendering for the OA experience. In addition, Outlook.com also leveraged this infrastructure. So we decided to make a concerted move with Exchange 2016 and depend on this infrastructure for all usage, whether it's Office 365 or Exchange Online, so that the same experience is exposed regardless of which OA session or Outlook.com session you end up utilizing. You get the same experience, the same capability, the same feature set. So the Office Web App Server provides us our rich browser-based versions of Word Online, Excel Online, PowerPoint Online, OneNote Online, providing us content rendering and the ability to do native editing within these documents, as we tried to demo successfully at our session earlier today. We'll get it right for the next session. Now, how does this data get accessed? Well, it is through an OAuth token that Exchange issues. The Exchange builds an access token. That access token is then consumed by the Office Web App Server infrastructure. It is evaluated. We determine the user credentials, what they have access to, whether they can edit, for example, whether they can edit the document, and we build the information around the capabilities of the host for this particular user and file. This access token then gives essentially an identity and permission control for viewing that data, which is important when we think of what we tried to show at that session, where you could have the document stored in SharePoint and not as an actual attachment on a message. We need to know all that information about the user, what kind of permissions they have within SharePoint to utilize this functionality. And that's how it's all accessed and rendered. And there are several sessions later this week that go into this in detail. So I highly recommend checking them out if you're interested in this new functionality. We also talked about the extensibility future. Exchange Web Services was the extensibility engine we built in Exchange 2007 and have iterated on successfully over the last 3 releases. With Exchange Web Services still ships in Exchange 2016. It has the same feature set that was launched in Exchange 2013. There's no takebacks with Exchange Web Services in this release. And all apps that you've built will continue to work against Exchange Server 2016. But where we are investing in going forward are the REST APIs. The REST APIs provide us a solution by which we can provide an open framework by utilizing open standards like JSON, OAuth, OData to provide solutions across all 3 modalities, desktop, web, and mobile, and allowing any of you that are developers to develop on whatever platform you want, whether that be something like Cordova or Python, not having to be forced to develop SOAP, which is what Exchange Web Services required. And it provides a much more capable infrastructure in terms of permissioning through the use of OAuth. We can now have granular, tightly scoped access, whereas Exchange Web Services was a full control impersonation modality. So you have a much more flexible framework here. The 3 APIs that we're releasing with the on-premises version is the Mail API, the Calendar API, and the Contact APIs. Their names kind of describe themselves. If you are interested in finding out more, all of these already ship in Office 365, and we already have all of it documented and available for evaluation and development right now, and that's on the website dev.outlook.com. And there are several sessions later this week that go into detail on the REST APIs. But of course, that leaves us with one other solution that was developed against. Everybody can hang their head in silence for a second. The MAPI CDO library. It is truly dead this time. I told you all at MEC that the Exchange 2013 would be the last release, and so I'm happy to say that I was able to keep that one promise. We will be blocking access for the MAPI CDO library to connect to Exchange 2016 servers altogether. So it is entirely unsupported against Exchange 2016. So any apps that utilize the MAPI CDO library, BlackBerry 5X, need to move forward, either by upgrading to a newer release that supports something like ActiveSync, or by taking advantage of the REST APIs or Exchange Web Services to offload that feature set. So client connectivity. Public service announcement. Riding your bicycle while looking at your mobile phone, inevitably you will hit something. My son loved this slide. He couldn't stop laughing. Pow, it's like Batman 60s cartoons. So the client protocol architecture, very similar to Exchange 2013. The key difference is that obviously the front-end services, the client access services, and the back-end services on a single machine. But that doesn't necessarily mean that everything is local and happens locally on that machine. I have my Internet Protocol clients that are utilizing HTTP as our authentication mechanism. Goes through the load balancer, authenticates against a Mailbox 2016 server, and authenticates, goes through the HTTP proxy ASP.NET application, and we make a decision on where to route that request, to proxy it to the Mailbox server hosting the active database copy. Notice the protocol used between the HTTP proxy layer and the backend layer is the same protocol as what the client utilized, HTTP. This is how we remove the dependencies around versioning and functionality and geographical affinity and user partitioning. We're now utilizing a protocol that is adapted to highly latent, high utilized network, WAN networks, internet networks, spotty networks, as opposed to RPC, which required a well-connected, low latency network to communicate. If it's an IMAP client, similar behavior. We will utilize IMAP or POP as the protocol to proxy to the Mailbox server hosting the active database copy. Same with SMTP. The only one that's unique is telephony. Telephony, we will issue a redirect once it's authenticated so that that SIP and RTP session can be established directly with the unified messaging component on the Mailbox server that's hosting the active database copy for that user. MAPI HTTP. We introduced MAPI HTTP in Exchange Server 2013 Service Pack 1. It was disabled by default. But it was a new connectivity paradigm because it removed the dependency on RPC as an intermediary. That was a huge win for us. RPC, as great as it is not owned by the Exchange development team. It's owned by Windows, and it is the most widely used protocol stack in the Windows ecosystem. Anytime there was a bug or an issue, or anytime we felt we wanted to enhance the RPC protocol, like adding better diagnostics in the header information, we couldn't do it because of the fear that it would potentially destabilize the entire ecosystem with those type of changes. I mean, it's a very old protocol, and so any changes are highly scrutinized. So we decided to remove that intermediary layer and just instead send the MAPI protocol to encapsulate that in HTTP. We own MAPI, so we can make any investments in the MAPI protocol we want. So that was the intention for MAPI HTTP. It is now going to be enabled by default in Exchange 2016. We've made some enhancements for Exchange 2016 compared to what's shipping today in Exchange 2013. Exchange 2013 today, it's an on or off switch org setting. It's either on or off, and there's no user flexibility there. In Exchange 2016, we will have per user control on that feature. So you can choose to have a set of users use MAPI HTTP, or a set of users use EWS or ActiveSync or Outlook Anywhere. You have that entire control via the SetCas mailbox. In addition, we also introduced a new behavior to control whether AutoDiscover exposes the external configuration for both MAPI HTTP and RPC HTTP. All right, we got one who likes that feature. It's always one. It's good. We did well. From a requirement perspective, you have to be running, obviously, Exchange 2013 or Exchange 2016. You have to have a supported Outlook version, like those KB articles that I mentioned back a few slides ago. You need those as the minimum. The one nice thing about this feature is that it doesn't prompt the user with an administrator's made a change that requires you to restart your client. Yeah, we hate that dialogue. What happens is when MAPI HTTP is advertised via AutoDiscover, the client will note that it can utilize MAPI HTTP, but it will continue to utilize RPC HTTP as its default protocol until the client is actually restarted. That could be during normal schedules. The user shuts down his laptop for the night. The user decides to reboot Outlook. Whenever. It could be days, months, weeks. It doesn't matter to us. Whenever they finally restart the client, that is when they'll consume the new MAPI HTTP settings and begin working. Now, obviously, with us having it enabled by default in Exchange 2016, if you're an Exchange 2013 shop today that does not have it enabled by default, that means you will have to be prepared once to introduce your first Exchange 2016 server. That means having the load balancer configured correctly that has the MAPI vDir mapped. That means having internal external URLs configured correctly on the MAPI virtual directory so that when you install Exchange 2016 and run prepare AD, the configuration bit gets flipped. Users don't suddenly get advertised an incorrect number of settings for MAPI HTTP if they have the correct client version. So that's one thing to keep in mind. How does this look different from RPC HTTP? Remember, RPC HTTP, or Outlook Anywhere, we're leveraging RPC. RPC is a full duplex connection, which means we need to be able to send and receive on the same, send and receive at once. We can't do that with HTTP. HTTP is half duplex. So for every single RPC connection, we had to create two HTTP connections. One that was an RPC in, that was used for sending to the server, and one for an RPC out that was used for receiving from the server. Isn't that confusing? With MAPI HTTP, we don't leverage that paradigm anymore. It's actually somewhat similar to the way ActiveSync worked in many regards, because now we leverage a bunch of small, short-lived connections that go and actually pull and retrieve all the data, and we have a single hanging, long-lived connection that is telling the client when it needs to actually go do work. And all that work is, again, HTTP through IIS, whereas an RPC HTTP client ultimately hits on the server hosting the active database copy, the RPC client access service. That is not what happens in MAPI HTTP. Instead, we actually have the RPC client access service loaded in a MAPI HTTP handler application pool. And that's what handles all the processing and access through the database. So, in essence, we've reduced a layer so you get to your mail, your candy, faster with this new protocol. Connectivity flow. So how many are actually deploying Exchange 2013 right now? Okay. It's a fair number. It's very dark down at that far corner. I can't see well over there. So a few. How many of you are upgrading from Exchange 2010 to Exchange 2013? Okay. So for all of you guys, this story is very familiar. Because Upgrading from Exchange 2010 to Exchange 2016 is exactly the same story that we had for Exchange 2013. Upgrading Exchange 2010 to Exchange 2013. You deploy the Mailbox 2016 servers, you configure them, you test them out, you jet stress them, always jet stress. And once you're ready, you flip the switch, you reconfigure the load balancer to not use session affinity, you change the load balancing pool to point to your 2016 servers, and you're ready to go. A legacy user will authenticate against the load balancer, or be directed to a Mailbox server against the load balancer, authenticate against 2016. We will discover that user is on a legacy machine, and we will route that to a client access server, fully qualified domain name, in the site where that user's mailbox lives. And then CAS 2010 does all the data processing and rendering for that Mailbox 2010 user. Same thing if that 2010 mailbox lives in a different Active Directory site. It's simply a cross-site legacy proxy request to a specific server in the target Active Directory site. We don't utilize the internal or external URLs for this proxy. We always build the name based off the server FQDN to target. And we maintain a list of healthy versus unhealthy servers. And we also maintain affinity for that particular user request so that that session always ends up on the same target CAS 2010 machine. The only time we issue a redirect is for OA, when the external URL and that target site is populated on that Outlook Web App virtual directory, and we will issue a silent redirect that is single sign-on in the event source and target OAs have forms-based authentication enabled. Hopefully everybody has forms-based authentication enabled. Now, where it gets interesting is 2013. So, way back in the day when I did the first talk about Exchange 2013, I told you how CAS 2013 was simply an intelligent proxy. And it did nothing beyond making a decision on authenticating and making a decision on where to route that request. This is where the reality of what I talked about comes to play, because I mentioned how it removed version dependencies. Well, here's a version dependency. We have two different versions of the product, and I don't need to move the namespace. If I want to proxy to that Mailbox server, I don't need to do anything. I just install the Mailbox server. CAS 2013 will authenticate that request and proxy it to Mailbox 2016. No work needed to be done. Right? Now I can deploy my pilot server. I don't have to create a new namespace or any craziness like that. I can move all my IT staff over, and it just works. And this is something we're doing live today in our dog food environment, so we know it works. This isn't mumbo jumbo. This works. And it's better than just this. You can mix Exchange 2013 client access servers and Exchange 16 mailbox servers in the same load balancing pool. So you totally own the decision of when the namespace changes. You could essentially do a one-for-one swap as you add new Mailbox 2016 servers into the environment. You can put them in the load balancing pool and take 2013 client access servers out of the pool. You could say, well, I'm going to keep all my users going through 2013 until 50% of my load is on 2016, and then I'll just swap the load balancing pool. You own the end-to-end experience of when you make that change entirely. And it works whether it's a local proxy request, cross-site proxy request, or an OA redirection request. And it will be a silent redirection with single sign-on if both source and target are forms-based authentication. And just like 2013 can up proxy to a higher level version of Exchange, 2016 can proxy down to a lower version of Exchange, namely 2013. So we will still do a legacy proxy request to the protocol head. Now, remember, this is key because the client access services, that HTTP proxy, always authenticates the request, does that discovery of the mailbox, and then makes the intelligent decision of where to route. It will always proxy to the server hosting the active database copy when it's 2013 or later. So we bypass CAS 2013's infrastructure altogether in this scenario, whether it's a local proxy, a cross-site proxy, or a cross-site proxy. The only time CAS 2013 would be accessed here is in the event of an OA redirection, when you have the external URL populated. And again, that will be a silent redirect with the potential for single sign-on if forms-based authentication is on source and target. That's the beauty of the infrastructure and architecture design that we implemented in Exchange 2013. This makes it the most simplest coexistence story we've ever had and will ever have going forward. So, Outlook Web App server connectivity flow. How does this work? So first and foremost, there is a discovery URL, very similar to like Auto Discover that Exchange has, that the Office Web App server has, where Exchange or an application like SharePoint can go query what infrastructure the Office Web App server has and what file types it supports, like OneNote and Word and Excel. So we'll build that list. That list will be returned to OA. And then what happens is that you have an OA user who comes along, he logs in, and he goes and accesses a mail item that has a list of attachments. When that user accesses that message item, OA will go and build the access URL, the auth token, and that is necessary for the event that the client clicks on the attachment. So that when the user does click on the attachment, we spawn an iframe. That iframe loads and goes to the URL that OA provided, which is being directed to the Office Web App Server Farm. Office Web App Server Farm will then consume that access token, authenticate that request, and ensure that that request is authorized to access that particular file. It will then retrieve that content from the mailbox in the event that it is an attachment on the actual message, and render that content to the client in whatever application is being accessed, Word online, Excel online, etc. That's the flow. Now, there is some more advanced flow that I don't cover in this session on what happens when SharePoint's added to the mix, for like when you have SharePoint having the attachment as opposed to storing that attachment in the message directly. We cover that in a later session this week on the whole OA document collaboration story, if you're interested in that. So namespace. Just like with Exchange 2013, Exchange 2016 does not require all the namespaces that Exchange 2010 had. Most importantly, the RPC client access array namespace. That's gone from the picture. It does not come back in Exchange 2016. So there is, if you're upgrading from Exchange 2010, there is a slight reduction in the number of namespaces you have to deploy, depending on the namespace model, which we'll go into. But you have a wide variety or flexibility in your namespace planning. You can go with a single unified namespace. You could have regional namespaces to separate out specific regions. You can deploy namespaces per protocol if you want. All of that still exists. Obviously, the one recommendation that we do strongly always recommend is to leverage split DNS and to control, so that you can control directionality and connectivity based on whether a user is internal to the environment or external to the corporate environment. Now, even when doing split DNS, there is one specific recommendation we have there, which is that for Outlook Anywhere and MAPI HTTP, you have a separate, distinct namespace for internal versus external. That internal namespace is not exposed to the external namespace. So like outlookint.contoso.com as opposed to outlook.contoso.com. The reason why is the way Outlook consumes auto-discover requests, specifically with, as an example, Outlook Anywhere. Outlook always consumes the internal auto-discover response before the external. So if you utilize a single namespace for internal and external, and I'm external to the corporate environment, I get the internal response first. I see outlook.contoso.com. My client attempts to do a DNS record lookup for outlook.contoso.com. It gets back. It then attempts to connect. Connection successful. It thinks it's talking internally, so it then consumes the internal authentication settings for that configuration. If you're following our guidance, you have configured Kerberos authentication for your internal Outlook Anywhere settings. If you don't have a Kerberos proxy enabled on your internet, your client just failed to connect because they can't do Kerberos. The way to mitigate that is by having a separate namespace, that internal namespace that is not resolvable on the internet DNS. So therefore, when that happens, Outlook falls back to using the external settings, and we'll use the external auth setting, which you'll have as set as either NTLM or basic in your environment. So what is a bound model? A bound model essentially is nothing more than saying, I have a set of users that prefer to operate out of a distinct data center, and I only want them to connect to that distinct data center unless there is some sort of failure event that requires me to have them connect to another data center. So in this case, I have Sue, which exists, her mailbox is in DAG1, and her active databases are in the Western data center, and I have Jane in the Eastern data center, whose active database is located in the Eastern data center. And that's the preference I want. I always want Sue operating out of West, and I want Jane operating out of East. So I have two distinct namespaces, West and East. I will always hit the West VIP, which resolves to the West data center during normal activation, and she'll get routed to her mailbox database that contains her active database. Or I have Jane, who will utilize the East namespace and will be routed to her mailbox. And then in the event of failure of one of these data centers, let's say West is offline, I would change the West DNS entries to then point to the East VIP in a data center activation event. This is the model we had with Exchange 2010 and how to do site resilience in data center activation. That's the bound model here. What we prefer with Exchange 2013 and later is the unbound model, where we don't give any preference to user locality with respect to data centers. We are fine at having that user access either data center. So Sue, as an example, will do a DNS resolution for mail.contoso.com and get a round-robin response to either VIP1 or VIP2. We don't have a preference to which VIP she gets routed to. So 50% of the time, she could be routed to a data center that's not the data center that hosts her active database. Like in this example, she gets routed to VIP1, and she gets routed to the VIP on the right data center. Or she could have hit VIP2, and then she is proxied cross-site to her database that is located in the right data center. That's the unbound model. This gives us a single unified namespace. And all this was because of the architectural work we did in Exchange 2013, where we decoupled namespaces from high availability. So load balancing. What does that mean for load balancing? Well, as I've already mentioned several times, we don't require affinity at the load balancing layer anymore with Exchange 2013 or Exchange 2016, because affinity is maintained at the mailbox server hosting the active database copy. But that doesn't mean that the load balancing configuration is necessarily simple. We have to take into account other things like managed availability. Managed availability is sitting there on all our servers, evaluating the health of each and every component and making decisions based on the health of those components. And if certain monitors turn red, it will take action, like maybe taking the OA, resetting the OA application pool on a particular server. We need to ensure that the load balancer is fully aware of what managed availability is doing. Likewise, we need to ensure the reverse, that managed availability knows what the load balancer is doing. Because the managed availability also makes decisions based on the whole collective. It evaluates how many, for example, how many servers there are in a DAG, and it makes decisions on whether it will enact certain responders based on the health of those servers within the DAG. It does the same for the client access services. So we don't want to have some artificial solution taking servers in and out of rotation without managed availability's awareness. We want managed availability to become the authoritative source of whether something's healthy or unhealthy. The way we do that for HTTP is via the health check HTM. It's an in-memory file managed by managed availability that, when is available, gives the load balancer a 200 OK response, telling the load balancer that, yes, this protocol is up. Or it gives another response which tells the protocol that it's down. This then translates into a number of potential scenarios for how we look at load balancing and manage it. But first, I'm going to talk about connection management. How do we get all the requests to the load balancer, and how do we distribute all those requests across the load balancer to all the client access service, to all the Exchange 2016 mailbox servers or Exchange 2013 client access server roles? There are two options here when we're looking at something other than session affinity: round robin or least connection management. So both of them have their benefits and they have their drawbacks. For example, least connections has a very fast convergence time because it just distributes the requests across all of the servers based on how many connections a particular server already has. However, it has one significant drawback depending on how the load balancer is configured. And that drawback is if a server suddenly comes into the load balancing pool, it has the least connection, it has connections of 0, right? So if it has a connection count of 0, it's suddenly the new guy for the load balancer to direct all the requests to. And in certain scenarios, like an oscillating type of event, a bug, whether in our code, in the load balancer, etc., that could lead to this new server being overwhelmed and inundated with new requests. Say when all clients are suddenly disconnected, and now they have to be reconnected. They're going to get sent all to one server because of least connections. So there is a way to mitigate that with many load balancers. Some of them have it enabled by default. Some of them don't. Some of them don't offer it depending on the version of the load balancer you deploy. But it is, and it's known by many different names. I've referred to it as the break. I think I wrote slow start on the slide. And it essentially says, instead of directing all traffic to this new guy, I will slowly ramp up the connections on this guy over a period of time. And that way, that mitigates that whole inundation request. So that is, if you are planning to use least connections, definitely enable that feature. If you don't have that feature, then you should probably deploy round robin. Now, round robin's drawback is that it doesn't do well with long-lived connections. Because if all your connections are long-lived, it's going to take a while for it to build this nice uniform dispersal across all the servers in the load balancing pool. Thankfully, we're moving away from long-lived connections. MAPI HTTP does mostly short-lived connections. So round robin doesn't impact MAPI HTTP as much as it's impacted by RPC HTTP. So those are your two options. Back to our namespace planning, layer, and load balancing. We have a few options. We talked a lot at the launch of Exchange 2013 about the fact that we don't require session affinity and we can go down to layer 4 type of load balancing, which essentially says I have an IP and I have a port. Well, I have the same port with HTTP. It's always TCP 443. So And I have an IP which resolves to a VIP, a namespace. So I essentially have one thing here. I have a namespace and a TCP 443. That's it. Whether I'm going to OA or ECP, it's all the same. We don't know anything beyond that. We just know we need to route that request to TCP 443. So because of that, we have to be very particular in how we look at our managed availability health check for the load balancer. And in fact, we'd have to pick a particular virtual directory that we'd want to actually health check, because we only have one rule on this load balancer. Route requests to the load balancing pool on TCP 443. That's our logic. If it comes in on mail.contosa.com on 443, route to this set of servers on TCP 443. That's the extent of our load balancing configuration rule. So we have to make a decision. Which protocol are we going to look at? The decision you'd want to make is the protocol that's most heavily used in the environment. Now, for most enterprises, that would be RPC HTTP or MAPI HTTP, depending on where you're at in deployment cycles. For the example, I chose OA. So as long as that health check for OA is green, all connections to this particular server go through, whether it's a connection to EWS, a connection to MAPI, or a connection to OA. It doesn't matter. This server is considered up in the load balancing pool. And of course, we'd have a separate rule for auto-discover, since that's its own distinct namespace. But if the health check failed on that server for OA, then all protocols for that particular server are down. That server is removed from the entire load balancing pool for the duration that the health check fails. So I only have per server availability in terms of health check capability at a layer 4 type of approach. So how do we solve that? There are two ways. The first one is we go back to layer 7, but we don't use session affinity. We terminate the SSL at the load balancer so that we can then determine where the request is going. Once we terminate the SSL, we know that it's going to OA, we know that it's going to ECP or OAB, and once we know that, we can then craft rules that health check each individual virtual directory. And so with this, we now get per protocol availability. So we don't have to worry about taking an entire server out of rotation. We only have to take out a protocol from rotation. So we get more granularity here. So if we have a failure, like on OA, the MAPI and RPC virtual directories are still considered up on this particular server. This is the approach that pretty much all the load balancing vendors recommend with Exchange 2013. F5, Kemp, they all have guidance that talks about how to configure it at this fashion. And it's what we're now going to recommend as part of the approach, because it makes sense. You get per protocol availability versus per server availability. The last one is another layer 4 approach. How do we get per protocol availability with layer 4? The answer is you need to have a distinct namespace or a distinct VIP for each protocol that you want to monitor in that manner. So you have namespaces for each protocol. Easy to configure, but operationally more complex. I now have multiple VIPs, I have multiple namespaces, I've got more stuff on the certificate. It's not what we recommend, but it is a viable alternative if you want to do layer 4 and get per protocol availability. This is another way to look at that. As you move left to right, you go from the most simplest solution, layer 4, with single namespace and per server protocol availability with the least functionality, or you can move the opposite way and get more functionality with a little bit more networking skill set increase by moving to a layer 7 no session affinity model. Obviously, there is a fourth approach, which is you would implement layer 7 with session affinity. We don't recommend that one whatsoever. There's no need for that in Exchange 2013 or 2016. What does our namespace planning and load balancing guidance look like for Office Web App Server? Well, Office Web App Server will operate in a bound namespace, regardless of your Exchange namespace. If Exchange is an unbound, your Office Web App Server infrastructure will be in a bound namespace. Now, the beauty is that this bound namespace has no data center activation steps. And here's why. I have a user. His mailbox is located in West. He authenticates. He needs to access an attachment. He'll do that discovery. Exchange will do that discovery and find that we have OA West in that data center and access the OA West infrastructure for that user to access. If the user hits the Eastern VIP namespace and gets proxied across, he'll get proxied across to the database server, to the mailbox server hosting his active database. Remember, the server that hosts his active database is the one that does all the OA rendering. So it's the one that determines what namespace to use for the Office Web App Server URL. So even if the user hits an Eastern VIP, he will never get access to the Eastern Office Web App Server infrastructure. The only time he'll access that is if his database is activated on a server in the Eastern data center. So that's why we don't have to do any namespace manipulation, because it'll just work automatically as databases are activated in the opposing data centers. The other key thing that is required with Office Web App Server is persistence, to ensure that while you're editing those attachments or files, that there is no loss of fidelity by hitting another server in that farm. It's okay, Jeff. So, the 2016 preferred architecture. It's the only architecture we want you to deploy. Period. Don't do anything else. What does it look like? Well, from a namespace perspective, a single unified namespace. At the very least, per protocol. You have your auto-discovery namespace and your HTTP namespace. You may use that HTTP namespace for your IMAP namespace. You may have a separate one if you want. It's totally up to you. We will have, for Outlook Web App infrastructure, a namespace deployed per data center. For our load balancer configuration, Exchange will be configured without session affinity, with one VIP per data center, utilizing per protocol health checking. In other words, layer 7 without any session affinity. For OA, for Office Web App Server, I hate that name in the acronym. You have to have session affinity for your load balancing VIP. How you manage this single unified namespace for Exchange and route those requests to both data centers. Round-robin DNS is the most simplest form. If you have geographical DNS, that works as well to ensure that that traffic is distributed equally across the data centers. From a DAG architecture, you'll have a DAG deployed across one or more Active Directory sites. Yes, one or more Active Directory sites. Our recommendation is you do not stretch an Active Directory site across 2 data centers. How many of you do that today? Yeah, don't do that. The key reason is that in Exchange 2013 and later, we made, prior to Exchange 2013, transport was a single point of failure. Because the primary copy, once it's delivered, the only thing you have left is a shadow copy in transport dumpster. And if that copy's lost, you don't get any recovery in a lossy activation. Beginning with Exchange 2013 and later, we now maintain multiple copies of the message to ensure that there's no one single copy that you depend on. The way we do that is we make a copy on another transport server in the DAG that message is being delivered to, giving preference to a mailbox server in that DAG that is in a different Active Directory site than the one that's hosting the source copy. And then we retain both the source copy and the shadow copy in SafetyNet for a period of time to allow for a lossy activation recovery scenario. So if you deploy a single stretched Active Directory site we have no knowledge of where those mailbox servers are in relation to one another, and we could simply create that copy on the server in the rack right next to it. And thus, you have a single point of failure. So having two distinct Active Directory sites removes the single point of failure in that type of architecture. The DAG is always going to be symmetrical. I don't want to see any more asymmetrical DAG designs. Same number of servers in both locations. Same number of database copies in both locations. Preference being 4 copies, 2 in each data center. Because it's symmetrical, that means it's an even number DAG, which means you have to have a witness. Our preference is that witness is placed in a third location. That's either a third data center that is connected to both, that has connectivity to both of the data centers hosting the DAG members, or it is placed in Azure so that you can have a data center, an automatic data center activation if need be. We also will not have an administrative access point on this database availability group, removing a complexity point, because now we don't need to worry about a network name and IP address resource. And we will not have multiple networks. There is no need to have a MAPI network and a replication network anymore. We only need a network. And guys, that network is not teamed. Right, we don't need it. Why don't we need it? Because you should be driving down toward a model where all recovery models do the same thing, activation of another database. Doesn't matter if it's a hardware failure, a disk failure, a motherboard failure, a NIC failure, a power supply failure, a rack failure. All of it should go to, oh, another database copy is activated. There should be no multiple complexity in operational procedures. It should just be drive towards a single recovery model, and that's Exchange's recovery model, activation of a database copy. So you don't need redundancy elsewhere because you have it built into Exchange. From a database configuration, as I mentioned, 4 database copies. One of those copies is lagged with a 7-day replay lag time, and SafetyNet is obviously set to 7 days as well. And you'll have native data protection because you don't need a tertiary or that would be a 5th backup, an external backup. I'll say that any longer. We provide all the features you need for backup within the product itself. And then from a server design, servers are going to be deployed on commodity hardware, dual socket commodity hardware, 20 to 24 cores, up to 196 gigabytes of memory. You will deploy JBOD storage, 7,200 RPM disks. Battery back controller is a must, even in JBOD storage. I've had a few escalations where customers did not deploy a battery back controller with JBOD, and they were not able to meet the I/O requirements and ensure that data is not lost in the event that there's an issue. Every 7,200 RPM has multiple databases and their associated log files and their associated content index. We will have at least one disk that is a hot spare for auto reseed so that in the event of a disk failure, it can be automatically reprovisioned and copies reseeded to it without any administrative overhead. All data volumes will be formatted with the resilient file system, beginning with Exchange 2016. That is a requirement. That is something else that is a benefit by moving to Windows Server 2012 R2 and Windows Server 2010 and not supporting, for example, Windows Server 2008 R2, which didn't support the resilient file system. And all data volumes are encrypted with BitLocker to ensure that data is not compromised in the event of a disk failure and replacement. So what this looks like, let's say I have 2 regions, European and North America. I will have a unified namespace. Now, in this example, I show a regional namespace approach where I have the North America VIPs pointing to northamerica.contosa.com, and I have the European VIPs pointing to europe.contosa.com, and requests are round robin within that particular region. However, I don't need that. I don't need regional namespaces. Because I could deploy a geographical DNS architecture where the client is then routed based on the client's IP to the appropriate VIP infrastructure within his particular region. And therefore, I can have a single worldwide namespace. That's pretty cool. That's what we do in Office 365, by the way. And Abram will talk about that in detail in his HA session later this week. So, I think you all know I'm a fan of large mailboxes. And I'm not a fan of stubbing. How many of you are still stubbing? You're the only one. You got, come on. Come on. Everybody else knows. So, we want large mailboxes are a win. You know, if you want to continue remaining relevant and on premises and fighting off the bean counters who say it's so much cheaper to move to a cloud-based system, you need to be able to provide a large mailbox to your users, because that's the win that we provide in Office 365. Large mailboxes, 50 gigs out the gate, unlimited archives when you deploy an archive mailbox. So you want to design toward that, whether it's a single mailbox, large mailbox, or an aggregate that includes a primary mailbox and an archive mailbox and the recoverable item set. And no, you should not separate the primary mailbox from its archive mailbox. Keep them on the same database. There's no point in separating them. You're already on the lowest commodity storage with 7,200 RPM disks. No win there. Want to get rid of those stubbing mechanisms because now you have full fidelity feature set within the client. You've seen all the new Outlook clients that are coming out and how we're providing a uniform experience across all device platforms. You no longer need to rely on PSTs. You have all the controls to suck that data in. We even have drive shipping options available to allow us to suck it in for you into Office 365 if you want. And you can get rid of them and block them and have the nice large mailbox experience with that super cool fast search that we talked about earlier today. And you can finally eliminate that third-party archive solution that is on commodity storage that we can run on. And then you have the slider in the Outlook desktop to control that PST or OST size in the event that you're deploying solid-state drives that don't have the capacity you need for your mailboxes that you're deploying. So in summary, our building block architecture provides various levels of flexibility and extensibility, load balancing, namespace, our high availability, site resilience. Our coexistence story for Exchange 2016 and Exchange 2013 is the best one we ever have, where you finally get to control when the namespace is moved. And obviously, the preferred architecture is the way to go. It reduces the complexity out of the infrastructure and provides all the resiliency capabilities you need to meet your levels of service. Simpler is by far better. And leverage the large capacity 7,200 RPM disks to meet those capacity requirements that you need to import all that PST data. With that, I'll thank you. We have a number of sessions still throughout the week.